Ready to get started?
Yeah, we're ready.
All right. Hey, everybody. Good evening. Thanks for joining us. Welcome to our Wisconsin Databricks user group meeting. My name is Ryan Shiva. I'm with Databricks Technologies, and I'm going to be speaking here with Devin Vanderwood from Jockey. First, Devin is going to show you how his company was able to use Databricks to automate and optimize clearance pricing, And then after that, I'm going to show you about serverless on Databricks, pretty much the latest improvements, and kind of make a case for why you should be looking into and using serverless. First, just a quick shout out to Databricks community. I would definitely encourage you all to join. It's an online forum where you can ask questions and find out more about Databricks products. You can see the learning paths, the training, certifications, etc. There is also a group for Wisconsin, which I would definitely encourage you to join. You can either go to community.databricks.com, or we also have this QR code for you, and then you're able to log in with your Databricks account or create one if you don't have one yet. And then also we have a Wisconsin user group on the Databricks community forum. So here's a QR code for that. And I would definitely recommend that you follow that. There's also a Wisconsin user group for Databricks. So if you follow these, you'll kind of stay up to date with the meetups and events that we're doing, and also keep up with the discussion. So now I'm going to hand it over to Devin, and he's going to talk about his machine learning project at Jockey.
Thanks, Ryan. So today I'm going to be talking about a great use case for Databricks jobs at Jockey International. So at Jockey, we are the American undergarment company. We sell underwear, t-shirts, things like that. And I'm going to be walking through an end-to-end use case that we are pretty excited about and has been a significant driver for our business. So Databricks job in real life at Jockey International.
All right, so up next, we're going to be talking about serverless on Databricks. I'm going to make the case why you should look into serverless and consider it for your interactive notebooks and also your scheduled workflows. So with classic compute, that's been around for a while on Databricks, and it's got some different issues. So the first thing we're going to do is kind of look at some of these key limitations with classic compute and see what sort of inefficiencies your team might struggle with if you're scheduling your jobs or running your notebooks with classic, and why you might want to rethink your architecture and consider serverless. So some things that teams spend quite a lot of time on is first setting up networks. This is making sure you've got your IP ranges, your subnets, etc., configured correctly. Security and compliance can take quite a lot of time, making sure that all of your clusters comply with like whatever you're looking for in terms of like vulnerabilities, exfiltration risks, networking controls. You also want to make sure that your workloads run well, efficiently, and that's making sure that you're not running into cluster failures, not too slow, but also you don't want to be like over provisioning your clusters because you're just going to waste a lot of money. And then lastly, upgrading DBRs. This could take quite a lot of time, especially depending on the complexity of what you're running. And you really want to get your workflows on the latest DBRs to get the latest like benefits, staying compatible, having the latest security patches and performance improvements. So if you're still using classic compute, you're probably running into all these different problems. And so when you're building a new data architecture, or if you are trying to migrate an existing stack, you should really be considering serverless as a part of your architecture on Databricks. So I'm going to highlight these kind of problems that serverless was created to solve, and we'll see why both your new and also your existing workflows would benefit from serverless. So there's this idea of different personas on Databricks. You've got data engineers, machine learning engineers, data analysts, and data scientists. And now all of these different users want access to the data. And the data could be either like structured data, semi-structured, unstructured data, and you want to give these different teams different levels of access, and that access also needs to be very reliable and performant. And that means, so you only want like people that should actually have access to the data to be able to access the data, and also to be able to just kind of access things in an easy, very like unified, discoverable way. And then another thing, you would want compute that is elastic enough for all of your different use cases. If you are using classic compute, I don't know if you like looked into the classic compute settings, but there's like a lot of different things to tune, a lot of different settings. It can be kind of overwhelming, especially for new and experienced users. And that's not like easy or user-friendly, which is not what you want. So now the question is, how are you actually able to scale this in a sustainable way? And this problem is really what serverless was created to address. And I would say, so whether you're building its new architecture or existing architecture, serverless could still help you address those problems. And one more thing is that serverless is really kind of the future of the platform. Databricks this is definitely what they're pushing, what they're moving towards. So if you want your workflows to kind of stay current and definitely like the new products, DLT, et cetera, on Databricks are going to be more focused on serverless. There could be who knows, someday maybe, serverless is the only option, or classic is, like going by the wayside. We're not there yet, but definitely that's what Databricks is pushing and moving towards. So now I want to just look at some of the key value drivers behind serverless. There's 3 different aspects that you should consider that kind of drive the value proposition. First, serverless is simple and fast. It makes it just super quick and easy for basically any data practitioner to get into Databricks and to just start developing things that actually provide the value, and you're not worried about managing like the infrastructure. And next, serverless helps you manage and govern your costs. You can reduce your consumption, and that means that you're only paying for the resources that you actually need and use. And finally, serverless has reliability improvements over classic. It reduces your downtime. It's got failovers, and so that makes things a lot more reliable. And then its security model ensures that your code is running in a very secure and isolated environment, and that's all just kind of out of the box by default. So now I kind of want to look at some of these points in more detail, and I'm also going to talk about some examples that kind of highlight these benefits. So maybe the core, the most important idea behind serverless is it's just simple and fast. You get started a lot faster because there's not these knobs that you need to configure compared to your classic. I've definitely seen firsthand, if you're a practitioner that's new to Databricks, you might over provision resources and you make other like suboptimal configurations that are just wasting money. And that's when you're setting up a cluster, which you do not have to do with serverless. Serverless also has got an advanced autoscaler. And so that will just automatically provision the resources for you. And that's based on the demand of your actual workload, very customized. So good for pretty much any practitioner of any experience level. And then you've got the fast startup of serverless. Your cluster could start in seconds instead of minutes. And that's because Databricks maintains a warm pool of resources for you. And that Databricks is actually like predicting how many resources they should provision at any given time. And that's kind of where they're able to like lower the cost by having this warm pool per region. There's some other optimizations that helps reduce the wait time, like environment caching is one of them. We'll talk more about that later. So myself have used both serverless and also classic compute while I'm developing interactively with Databricks notebooks. And I think that, I really prefer working on serverless if I can. It definitely like reduces the friction for you, not to have to wait like 5 minutes every time if your cluster stops. If you're like ready to be done and you want to terminate a cluster, somebody else might be using it and that could like disrupt what they're doing. So you have to go and check and, hey, is there any notebooks attached? And then if you're letting clusters auto terminate, if it's whatever your setting is for auto termination, it could just be like sitting idle for like half an hour to 2 hours every time, depending on what your setting is. So just a lot of wasted time compared to serverless. And lastly, we'll look at the efficiency of serverless. So the reason serverless is so efficient, first of all, it's fully managed for you. So you don't have to spend time like configuring high availability of your networks. And then a key idea behind serverless is that it is versionless, meaning you're not spending time on these DBR upgrades or like hitting these out of memory errors. And we'll talk more about that later. Your workloads will get automatic improvements as these DBR versions are upgrading seamlessly in the background for you. And that means that you need to spend a lot less time just like manually testing your code, working out bugs related to the DBR stuff. Story about that. So once I was troubleshooting an error for a job, and it was this really like, how Spark sometimes spits out these really like cryptic errors and had nothing to do with what the actual problem was, but it was kind of hard. It was a little goose chase trying to figure out what the problem was. So eventually we were just trying different things and we upgrade the DBR version for the job, and lo and behold, that actually fixed the problem for us. So that's just to illustrate that like if we didn't think to do that, then who knows how long we might have wasted just trying to like fix this Spark failure. And so that's the kind of thing that serverless can help you avoid. And that is like great for just not just notebooks running interactively, but also jobs. So if you're like, why would I use serverless on a scheduled job? There's more to serverless than just the fast startup time is my point. Now, another huge benefit of serverless is this idea that you're really only paying for what you use. Like when your workload runs and what you're actually utilizing, that's what you're paying for. If Databricks scales up your serverless compute too much, they actually don't charge you for that. And you also get these like cost governance tools. So for instance, resource caps, like your notebooks can auto terminate, like your queries will auto terminate if they run too long, which is there's a default setting, and then you can also configure that. We'll look into the cost controls later in the presentation. And another kind of observability piece is system tables. You're able to view cost metrics. There's also a pre-built cost observability dashboard for you. So that's, again, just like out of the box, able to access and view in your workspace. And another tool, you can set budget alerts. This is if you want to have more control over what you're consuming and visibility. And then as an additional point, serverless really reduces the complexity of your infrastructure cost, since you're only getting billed for Databricks infrastructure and DBUs from Databricks, so you don't have to worry about like cloud vendor charges. And then lastly, there's the reliability piece. Serverless is first very secure by default, and Databricks is just managing the security for you. You have multiple isolation layers. You've got data encryption, and then also this strict hardening and vulnerability policies. And of course, like in Unity Catalog, all of your data is secured by default. And then secondly, serverless is a lot more stable than classic compute, which is reducing the amount of interruptions you'll face in your workloads. And again, that's because of that warm pool of resources that Databricks maintains. So that helps shield you from outages. If your instance winds up failing, then serverless can provision another running instance from that worm pool. And not only that, but it can fail you over to a completely different instance type if there's like an outage in your region or something. So between instance types as well. Yeah, so that one more point is just that serverless will power your like entire Databricks experience, whether it's like DLT, notebooks, jobs. We're going to look into that more later. Yep. Any questions so far before we move on? Yes.
If you have a Databricks job that just requires an unholy amount of consistent compute, would you say that serverless would be good in that case, or would a vendor be better off just using a regular reserved cluster size in terms of cost?
Yeah, that's a really good question.
Like
so
a scheduled job that occurs every night with a consistent bandwidth that's guesstimated.
yeah, so when you say yeah, that's a very good question, and I'm just going to say it definitely depends. And so with a large job, the consideration is going to be obviously a larger job is going to require larger compute, which is going to be larger cost, and there is a higher DBU charge associated with serverless compared to classic. So that is, I would say there's more of a motivation to use classic if you can. The considerations would be if your team is going to be like tuning and like upgrading DBRs, ready to put in infrastructure cost to make your job more efficient, then yes, you can definitely reduce cost by using classic compared to serverless. But if you're not willing to put in that time, it is actually possible that serverless could be cheaper in the end for you, which we'll kind of explore how that could be later. Another consideration is just your SLA. So regardless of the size of the job, if you have some like low latency, like you just need the job to run right away and you can't like wait a few minutes for the job cluster to start up, that could be one example. So yeah, there's different considerations where I couldn't just give you like a blanket yes or no. But yeah, definitely like the more compute you're using, the more you might want to consider classic if you can handle the infrastructure cost. Any other questions?
I just don't know the answer to this. How does serverless work if you have data residency requirements? Like all my data cannot be in Canada. It has to be in Canada.
Is this cloud data?
Yeah.
Okay.
It's
yeah.
just
So
compute. So if
yeah.
you store it in Canada, in your hard drives are somewhere in some Canadian data center, fine. But do we have to worry about, that Databricks might shift that serverless work to a US-based data center?
It goes by region. So it just kind of depends on your region. I don't know if the regions overlap. Like I know about the US regions, but I don't know about like if you have a region in Canada.
There must be a reason for the Canada as well.
So instead of like US East 1, maybe Canada 1.
Yeah.
Or something
Yeah.
like that.
But no, so yeah, you're guaranteed if you are in a certain region, you're only going to get instances from that region. Yes,
That is
yes.
guaranteed.
Correct, yes. Yep. Yep, excellent question. All right, so moving on. And yeah, by the way, feel free, I don't know if I said this before, feel free to like interrupt me if I'm like talking past something and you want some more clarification. I don't mind, I love it. But I'll also pause periodically to get some questions when it makes logical sense. So now just looking more at like how does serverless actually work? I want to kind of examine like what does it mean from a technical standpoint, how the platform manages the compute, the scaling, and the resource allocation, and then that eliminates the need for users to be touching and tuning the infrastructure. So I've got a diagram here, and that's going to kind of illustrate it for you. So if you're a user in a workspace and you request some compute, there will be a pool of warm VMs. For every region will have their own pool. And once a query comes in for you, then Databricks will allocate free instances from that pool. And that is specifically for your workspace. So once the VM is allocated, that's yours. It's not going to be like shared with somebody else. So that's like kind of the security piece, the isolation piece. just your instances, and that forms a cluster, serverless cluster, and then it will run the workload, run your query or whatever you're trying to run, your notebook. So that's kind of like having an instance pool per region, but like I said, you've kind of got the security guarantee, the isolation, because no sharing once the VMs get assigned to you for your workspace. And so how does Databricks actually make that efficient? Well, so because you've got all of these instances for each region, kind of like all the individual users sort of average out, and then the compute demand kind of it becomes a lot more predictable. Databricks also has this like AI model that they run, and they'll try to predict, okay, given that we've got certain jobs scheduled at certain times, there's a lot of jobs, that run on serverless, and then certain times of day for certain regions will have certain levels of demand. They will predict how many warm instances should we have in the warm pool. So that's kind of how they're able to keep costs down for everybody by not allocating too much in that pool. And then I'll just kind of little tangent. So at the current company I'm working at, we had a batch job, and this job was running once per day. And then every once in a while, that job would just have a failure because it turns out that the Azure instance type that was required for our cluster just was not available in our region, or like we were using them all up, so there just was not one available. And so that was classic compute. But if this was serverless, that's kind of the sort of failure that you could be protected from with serverless, because if you're using one instance type that's not available, it will fail you over to another instance type. So that's like when you're like calculating the cost of serverless versus classic, you also need to consider this added, time saved, where you're not like troubleshooting these sorts of errors, because serverless is just protecting you from these kinds of failures.
Wait.
Yeah, questions?
That if you had a job, it would automatically try to shove you in different permutations of configs until one would work.
Yeah, like when you say permutations, like if you're running on a certain type of VM with Azure, for instance, but yeah, that's not available. What will happen is it's like from your perspective, the job won't fail; it will just keep running. But then Databricks will like shuffle you over. It will provision from that warm pool another instance type that is maybe similar, or it detects is suitable for your workload, and then it will seamlessly transition over to using that one. And you might notice like something runs a little longer, but you actually are like insulated. You don't notice that this is going on in the background.
But like, let's say that it's like a bug related to DBR versions. Would it be able to figure that out for you, for example, in terms of like?
Yes.
Like,
yeah.
That's what I meant by permutations, in terms of like the configs that you would normally have with Classic. It would at least try like one of a few presets until the job would potentially work.
Yeah, that's a great question, and that's something I was going to get into a little bit later, but we can certainly talk about it now. So what you're talking about with the DBR versions, very good question, and the answer is yes, serverless can handle that. There is a behavior called pinning. So what happens is the Databricks DBR version is updating seamlessly in the background. You're getting like the latest DBR, but what happens if your code that you're trying to run is not compatible with that DBR version? Well, what happens is the Databricks will try to run your job or your notebook with serverless. A failure will occur. Now the user is not going to be exposed to that. What will happen is Databricks says, uh-oh, this latest DBR version does not work. We are going to fail you down. We're going to pin your workload or your workload on a lower version. And then as long as that succeeds, we are going to keep your workflow pinned at that version. So we're not going to try to run you on the latest version. We're going to try and run you on the version that worked. And then the Databricks team will be automatically notified, hey, there's a failure that occurred. Here's the job. Here's the stats. The Databricks team will work on fixing that particular error. And then once it's finally resolved, then they'll automatically bump you back up to the latest DBR. And you would never know that even happens because it's all just like in the background. But yeah, excellent question. Anybody else?
That's done systematically.
Yes, yep, systematically and like very much under the hood in the background. The only time you might notice it is if you're like looking at your costs and let's say you're like running a job, you haven't changed anything, but then you realize all of a sudden, hey, my cost is 20% cheaper, what happened? Well, maybe you were bumped up to a new runtime version that has like a certain efficiency with like if you're doing like a certain join or shuffle or whatever you're doing in your workflow, and that wound up being more efficient. I heard like a speaker talk about like one time they had a client and they got a call and it's because their job ran more efficiently, and they're like, why? Well, yeah, that's the reason why. But yeah, we'll look at that a little more later too, but yeah, it's pretty cool technology. All right. So now we are really going to kind of look at under the hood, how does this architecture work? We're going to kind of compare like classic versus serverless, and what are some of the changes that were made to how the resources are managed, how the executors, driver, look at that kind of thing. So definitely serverless is very different from classic. On the left, we've got traditional Spark architecture. So this would be like a classic cluster. You would have just you'd have a Spark driver, and then that has all of your packages, your Python, your operating system, your notebook code, all running on that driver. And then you have workers that get controlled by the driver. Whereas in serverless, by contrast, the REPL gets taken out of the driver, and then it's running in this separate small provisioned VM. And then that VM is what's running all the Python packages, your environments, and your notebook code. And it's also running something called the environment version, which when I first heard this, I was a little confused because I'm like, wait, isn't serverless versionless? Well, what they mean by versionless is, yes, there's still an environment version, but within an environment version, you're still sort of getting like seamless DBR upgrades. But the environment version, you're able to set this in the UI when you're configuring your serverless. This changes a whole lot less frequently than DBR. And then you get like 2 to 3 years of support when you pick an environment version. And so that environment version contains the breaking changes of upgrades. So if you change environment versions, then yes, it could break your workflow. You might need to do some code migrating if you are updating that. And then back to the diagram, we've got a driver, and that has your executors, and that runs like what you would call the DBR classically. It's not technically the DBR because it's serverless, but kind of like what you would call the DBR, that's what's running. And then that gets connected through Spark Connect, sort of like a standard interface for interacting with Spark. And so this is really what makes versionless possible, is like your workload is just improving in the background. You're constantly getting updates. You don't even know about it. And then those upgrades will, as long as you keep the environment version the same, they'll be backwards compatible with your workload. Or if they're not, it'll fail. It'll pin, to a certain DBR, and then Databricks will fix it for you. And so that's kind of how the workload can be a lot more efficient with serverless. Questions about that? And now we're just going to look at more like the advantages of serverless architecture over classic, and it'll kind of illustrate for you why organizations are adopting it, why there's all this interest. So looking into the automatic upgrades a little more, so when Databricks first released serverless, they were on DBR 14, and now it's at 16.2. which means that over 1 billion workloads have actually been upgraded, over 20 different DBR versions, and customers just don't notice. They just get the improvements and patches and performance benefits. And there's no disruption to your workflows when they're running. The pinning behavior prevents errors due to these DBR upgrades. And then another big advantage is environment caching, which I mentioned before. So the way that works is when your cluster starts up, it needs to install, certain Python packages, certain things needed for your environment. And environment caching prevents you from having to re-download and wait for the installation of all those packages. Because if your workload runs once, and those are downloaded, then they just get cached, and then they can just be reloaded in seconds on subsequent runs. So that actually saves a lot of time, which is, you know, saving cost as well, saving DBUs. Just a kind of an overview of some of the key technologies that make serverless possible. You've got your warm pool of VMs. It's managed by AI. You have a horizontal autoscaler. So if, you know, the compute requirements for your jobs are scaling up or down, serverless compute will scale with it. Serverless has got the versionless component with the environment version, so you don't have to worry about the DVR. Photon gets automatically enabled with serverless, so your jobs will just run faster. You can get the latest features. Databricks serverless is also really very secure. And let's see, you've got vertical scaling. So if you need to get provisioned a more powerful instance, serverless will kind of auto detect that and scale that for you. So now we're going to get into cost, but before we do, like, any questions about the architecture or the, you know, the technology behind serverless? All right, so let's talk cost. Now, I will mention that, you know, if you didn't know this, serverless is more expensive per DBU than classic. So you might be wondering, will serverless actually save me money? Is it a good option if I'm actually trying to reduce my cost? And I would say, yes, it certainly can reduce your TCO, even if it costs you more DBUs in the end. So this diagram kind of illustrates that point. On the left, first, you've got your classic compute cost. And so this is kind of made up first of your DBUs, which you'll see is low because it's classic. You're not charged that much for your DBUs. But then you've got infrastructure cost. And now the infrastructure cost is just the cost that you're incurring from your cloud storage provider, AWS, GCP, Azure, for your compute. And so obviously you're paying Databricks for DBUs, but you're paying the vendor too, cloud vendor too. And then on the bottom, it's operational cost. So this is just all the costs associated with, like, upgrading DBRs, doing the performance tuning, this extra stuff that's required with Classic that serverless just takes care of you for you. And then on the right, you have serverless cost. So while you'll notice, yes, the DBR or DBUs is a lot higher with serverless, you don't have your infrastructure cost since, you know, Databricks is managing that. And then you also do not have, or I mixed that up. You don't have your operational costs because Databricks is managing that. And then you don't have your infrastructure because Databricks is running that with VMs in the cloud, so you're not, like, provisioning them in your cloud vendor account. So in some cases, not every case, but in some cases, your TCO can be lower with serverless, even if you're consuming more DBUs. So now we're just going to look a little more closely at how serverless compute can work for notebooks. Specifically, this is one of my favorite ways to use serverless because that fast startup time, it's great. So I will say, first of all, very user-friendly because you just are able to, if you're like a new user, no matter who you are in the workspace, whatever your permissions, it's just like completely no knob and totally, like, easy to use and get started. So you'll see in that image, there's this little button here for compute. And if you want to attach to serverless, you just click that button and select serverless, and that's all you have to do. Then you're connected and you're ready to get started. And it might take like 5 or 10 seconds to spin up. And then, as previously mentioned, you've got that environment caching in your notebooks. So yeah, no more like waiting for these Python packages to install every time. You just have that cached and then you're ready to go. Less than 5-second startup. And then as long as serverless, you need to enable it in your workspace, but as long as it's enabled, all users will be able to access it. So that's really convenient for new users. Before, it's like if you add somebody new, then you're like, oh great, what cluster do they have permission to use? Do they have like create cluster permission, etc. But now it's just you add somebody in there ready to use serverless. And now let's look at serverless compute for workflows. So serverless has got, it's just a more efficient way to manage your compute resource. You can have less than 60-second startup time. Auto scaling and Photon get automatically enabled when you're using serverless. Auto scaling obviously is helpful for like reducing your total consumption, but also keeping up with the demands of your job if things are scaling up. And then Photon will make things run faster for you. And then it's just not having to worry about the infrastructure, configuring memory, processing engines, because it's just getting not only provision for you, but then continuously optimized behind the scenes. You've got the automatic instance type failover we discussed previously, DBR upgrades automatically, and then all workspace users can use serverless compute for their workflows, kind of like notebooks. So that makes things really simple for your new users. And then, yeah, just the really fast startup time is a big benefit when you're using performance optimized mode. And that's something we'll talk about on the next slide, is the difference. There's actually two different kinds of serverless compute you could use for workflows. So when you're using performance optimized, you've got the under a minute startup time. But yeah, we'll look at that in a second. One more thing to note is you can use budgets to control your cost. Again, something we'll examine further in a later slide. Questions so far? Yeah.
Can you set, like I know that for AWS it's a little harder to control billing and cost. Can you actually set like an upper threshold or just alerts?
Yeah, good question. So we'll talk about that a little bit later. But right now there are more. It's more of like giving you visibility into what you're using than it is actually controlling your costs. There's some things like, for instance, the 2.5-hour timeout for notebooks, timeout for like running an individual Spark query on serverless that are more like cost controls that are actually restricting the cost from occurring in the first place. But this is something that Databricks is actively working on and trying to improve. And like I'd expect to see this rolled out in the next quarter, next 6 months, next year. More of like giving admins the ability to say restrict the amount of serverless usage to certain users. So we'll talk about this in a little bit, but there's this yeah.
Sorry, second question. Have you noticed any real differences between Azure or other cloud providers for Databricks? Like I know that for AWS there's like S3 buckets that people use as data lakes, but have you noticed anything more practical besides just things like that in terms of differences for your UX?
Well, I mean, I will say that if you are if your company is using a particular cloud vendor for something else like identity or things like that, it is definitely helpful to have a Databricks instance that is using the same. Like for instance, my current organization uses Azure. We've got Entra ID because Azure is a first-party. Databricks is a first-party service called Azure Databricks. It's just kind of makes things a lot more seamless. You're able to log in with Entra. You're able to have like Azure Key Vault, Azure Secrets that you're kind of like integrating. You're able to provision like SPN, service principals that are authenticating without like the need for like dealing with like access tokens or things like that. So yeah, I would say there are benefits, but it is kind of minimal too. Like you could probably get by even if you're more of an Azure based, if you have a reason for using Databricks on AWS. Don't use GCP unless you have to, because usually they don't get the latest features as quickly. But yeah, go ahead.
Would the same notebook work on either, let's say, AWS or Azure? Like the question that I'm wondering is, what skills in AWS Databricks transfer to Azure in terms of like a hiring manager, for example? Like that's the kind of question that I kind of want to get at.
Yeah, not a lot that I can think of. I mean, obviously, like whatever, like if you're writing a Delta table, it'll be like different. You're writing to like an Azure storage container instead of an S3 bucket, but yeah, the code would be pretty much the same think. I'm not thinking of any differences, really.
I've seen things break that work in Azure but not in Google Cloud, just because
Mhm.
the back-end infrastructure is different. And so like some of the AI capabilities in Azure are actually more advanced than what's available to the general public in Google Cloud. And so like things just wouldn't work over there. And when we dug into it with Databricks, they were like, oh, over there in Google, man, you cannot get at language models like that, like we can in Azure.
Yeah.
So that's the only time I've seen problems. Usually it's just lift and shift and you're good to go.
Yeah, that's a good point. Like GCP definitely like doesn't have as many features, and they might get rolled out. They're usually rolled out on like AWS or Azure first, and then like GCP when they get to it. But yeah, you'll see that too. Is like in theory, running Databricks on every region should be the same, but in practice, like maybe something isn't like a private preview thing or a public preview thing isn't available in your region yet. So there are differences, but Databricks is obviously like trying to minimize that and make it more of like a universal experience.
GCP is now using VMs and not Kubernetes, right? That's a big shift within the last 2 or 3 months from an architecture standpoint. I think I read something, but I can't. I'll try to dig it up. But I think architecturally it's now the same.
They started out running everything on Kubernetes.
I think so.
Interesting.
I think recently they shifted to VMs within GCP, or like within the last month or two. I'll look at the article.
That would be interesting if things became much more fungible that way with code, because you can federate the data across Unity Catalog. I'd be super interested in working on that.
Back to the original question about cost controls. So Databricks has got a feature called budget policies. What this is a tag that you're able to configure at the account admin level. And right now, all it basically does is if you're running serverless, you'll pick a budget policy and then it will run under that policy. Then you're able to see in like system tables in your cost dashboard, okay, there was this much serverless consumed with this budget policy. So you're able to attribute usage to a certain team or project. And what they are working on right now, but it's not available right now, is the ability for admins to restrict the actual usage for a budget policy. So that's kind of one way that they're trying to work on building more cost controls into it. But definitely the cost control piece is very much like work in progress, trying to roll stuff out. Things are coming quickly, but that's the current state as I'm aware. Any more questions or? All right. And now we're just going to talk about the difference between those different serverless modes. And you've got performance mode or standard mode. Standard mode is a newer addition. It was announced at Data AI Summit this year. And this is a really exciting new feature because basically it helps you save a lot of money, essentially. So people look at serverless and they're like, I like the features, I like to use it, but it's really expensive. Well, this is kind of bringing cost down a lot more. And standard mode is currently what your workflow would be set to by default if you have a serverless workflow, but you actually can go in and choose to switch that on and enable performance optimized mode. So some of the differences, performance mode will have compute that runs 2 times faster than like a typical classic cluster. I think that's because of Photon. And it's also good for like jobs that require a very fast startup or like really high performance. Sometimes you'll have specific SLAs where you just need that very low latency, and that's kind of what performance mode is for. But now with standard, by contrast, that's like more equivalent, I'd say, to your classic job cluster. It's really good for jobs in DLT, and it's good for these workloads where you don't need that fast startup time. Like I said, it's like if you just got a job, the batch job running once per day, you don't care if it runs at 5 or at 5:05, just needs to run. Yeah, I'd say like most workflows are probably should be running on standard mode unless you have a really good reason to run on performance mode. Here's kind of a more detailed comparison that shows the 3 different compute modes. So first of all, on the right, that's your classic jobs. You're probably familiar with these. You've got a 4 to 6 minute startup time that's waiting for your cluster to spin up, for those resources to get provisioned from your cloud vendor account. And one thing to note is that when your cloud resource is spinning up, you're actually getting billed for that time. And then there's also some more time to actually like install your dependencies. Classic jobs usually run slower than performance optimized serverless. That's not always going to be the case. Like if you've got data ingestion where the speed of the job is depending on the network or the source system, that will not guarantee to be the case. But other things like transformations, for instance, shuffle operations, things like that, performance could run a lot faster. One thing to note about Classic is in a lot of cases, you can save money with Classic compute over your standard serverless compute. Like for instance, if you're using spot VMs, or if your team is, I'd say, actively optimizing the cluster for your performance and your cost. The problem is a lot of companies will not do that. You might just like set things up and then forget about it, and then your DBR is running out of date. It's running on not an optimized runtime. Maybe the like compute requirements of your job have changed and things are way over provisioned, but you're still just like spinning up a large cluster for nothing. So if you're not like optimizing that, serverless can save you a lot of money. If you're tuning these things, Classic can be cheaper. And now let's look at the 2 options for serverless. First of all, there's performance optimized, which we've kind of talked about already. Typically 2 times faster, starts up in less than a minute. The cost is really comparable to like an all-purpose compute cluster. And kind of a little side story. So that's a company I was working for. This was a while ago, but they had they had dozens of jobs set up. They were all running on this giant all-purpose compute cluster. And usually the CPU consumption would be like 2%, very underutilized because most of your jobs, it was batch jobs. Either they're running once per day, once every hour, or once every 15 minutes, and they were usually pretty short. So for that particular scenario, all-purpose compute was obviously costing them like a lot. And even if you had run this on performance optimized serverless, it would have like used so much less because it's like only provisioning the amount that you need at, the individual time. And so it would have like drastically reduced their consumption. So that point is just to kind of illustrate an example where serverless, they should have been using serverless, or this was a long time ago, so that wasn't really so much of an option. But that is a scenario I hope doesn't happen too often, but we're living in the real world and sometimes these things do happen. So yeah, don't just like count it out because it's way more expensive. You have to, there's the other side of the coin to consider is, are you actually actively optimizing things? Back to the comparison. For performance optimized serverless, that's best for like I said, the most time sensitive workloads. Let's see, and I think you kind of got that, but if you have that little switch in your job and you just switch that off, then you're running in standard mode. This chart kind of illustrates just like if you've got classic compute in your workspace, what are the serverless equivalents? So first of all, for DB SQL, you've got pro warehouses, that's your classic, and then serverless warehouses would be what you'd select if you want the serverless option. For notebooks, you can, for classic, you've either got all-purpose clusters or job clusters. And then we kind of talked about the serverless, either performance optimized mode or standard mode. The serverless equivalent to an all-purpose cluster would be like the serverless performance optimized cluster. because it's got that fast startup time, similar to all purpose, where you just can have it running and then your job can just start running right away. And then until very recently, there wasn't really like a serverless equivalent for your automated compute. But now, since you've got the standard mode, that's more analogous to the automated compute, the job compute, because again, you've got like that 3 to 5 minute startup time, but then it's a lot more affordable than performance optimized mode. Any questions? Okay, so now we're going to get more into the cost management side of things. When you're looking at cost management, there's really 4 different areas of cost control to consider. And I will say these different areas are at different levels of maturity with serverless. It's like a lot of work in progress, like I said. First of all, you've got observability. This is just understanding what is being consumed in my workspace, how much are me and my users actually spending. So for that, you've got the system tables that Databricks provides. That logs like very detailed information about every like action that's going on in your workspace. Now, one thing to understand between serverless and classic is with serverless, you've got a billing record of every individual notebook session. It breaks it down very detailed, granular level. With classic, you just know what's going on with spending for your entire cluster. So not so much high level of granularity with classic cluster mode. Let's see. Next element is cost attribution. So the idea here is understanding like what teams in your workspace are using what. And so you want some kind of tagging behavior. Now, what Databricks provides for this, I've already kind of introduced this, but budget policies, you can use it to have like chargebacks between different teams internally within your organization. Third, you want to prevent accidental spending. And so the features that Databricks provides for that is like some default limits. You want queries to auto-terminate if they're running too long. Those default limits are adjustable. You have timeouts that you can set in notebooks. And so if you're just like, leave a notebook running, you forget it's running, you're not just going to come back over the weekend and you've been running a query for 72 hours and you've got an angry boss, so that's what the timeouts are for. And then on the top layer, you've got more proactive controls. And in my personal opinion, these are a little bit lacking right now, but Databricks is definitely like actively working on getting up there to provide more of these entitlements, throttling, budget limits. So excited to see what's coming in the future for these. Here's just a picture of the cost observability dashboard, which I mentioned, just a really easy way to visualize your costs. Databricks gives it to you out of the box, and it's powered by system tables. You can break down costs by your different Databricks products if you want to see like what your jobs are running, what your SQL queries are costing you. You can break it down by individual job, notebook, so just like slice and dice, get really granular. You can create custom dashboards. They've got like a UI, makes it pretty easy. Now we're just going to look a little bit at cost attribution, namely these budget policies. So that's a feature that lets you enforce tags. And then we'll talk a little bit more about how this actually works. So you look for a setting called serverless budget policy tags, and they're read-only tags. You can pick one of these and assign it to your notebook. You might have access to just one of these, or you might have more than one if you're on like multiple teams or working on different projects. This is something that I personally use at my organization, or that was a weird way to phrase it. My organization uses these, so I've got personal experience with it. So it's like good for, like I said, kind of tracking. We've got like a lot of different projects, a lot of teams, tracking who's using what with serverless. So if we know one team is getting way out of control with their usage, you're able to dial that in. This is like a picture of how you'd actually create a serverless policy. They're defined at the account level, so if you've got a lot of workspaces, good news for you. You only have to create these once in the account. So at my company, we will typically create like where we're tracking things mostly by team, but there's a couple of big projects where we want to break it down by project, and so we have serverless budget policies for those too. And like when you are in the notebook attaching to serverless compute, depending on how the admin, if the admin has set this up, you will be forced to pick a budget policy. Questions about that? And now I'm just gonna talk briefly about some more safety features, such as notebook overspending. Don't have a lot to say about this, but just a couple of protections that helps prevent those like cost spikes. So serverless has got, by default, a max cap of about $200 per hour for any single workload. Should not be going over that. That would be like you've just got like an individual job running. You'll be capped at $200 per hour. There's a Spark setting called spark.databricks.execution.timeout, and that you're able to configure that if you want to hire or something. And it only applies to interactive notebooks, so this would not apply to workflows. The other thing is this particular limit, it only applies to Spark queries, Spark execution. So if you're running things on the Python REPL or something, that would not apply. And then one more thing is your timeout. It only applies per query. So this is not like for the entire notebook. So if you're expecting you have like, I don't know, a notebook with 10 queries or something, and you're expecting it to time out after 2.5 hours, it might not, because after one query, takes 2.5 hours, then it will just keep going on the notebook. So something to keep in mind. All right, we did it. Any more questions or anything else you want to know about with serverless? No? All right. Thank you all.